Good morning, everyone, and welcome to my video of my Capstone draft presentation. I decided to make a video because it seemed like the most expedient way to show everybody what I've been doing and where I'm going with my Capstone. So, as many of you know, I have maintained a web page for the past 2 years throughout the duration of this program, and I've been adding to it along the way. This is the web page right here that you see, a mathematics learning journey at weebly.com. And you'll see that I've got a number of things here. Not all of this is is part of my capstone, obviously. A lot of this here, like CT meets UDL, that was part of our, I did that during our second course, the CT course. Our third course on math teacher knowledge, I did some work on fraction operations. Then we had our math and art course. That's my work here. And what I have here is this section right here is what I'm working on right now for my capstone. And we'll take a look at that in just a moment, but first I want to show you this. So on July 3rd, I believe it was, we submitted our capstone plans, and this is part of what I handed in. I made a little map of what I planned to do. And if we just take a quick look at it here, I have it's kind of to me it's a map of the web page. Up here we have the main page, which has not changed. Then I had a landing page here for integrating coding and computational thinking with math instruction. And on this page I plan to summarize various aspects of coding and with mathematics in general, and then kind of present my perception of the Ontario context for it all, talk about challenges and barriers, and I quote an article here by Barr and Stevenson, and I'll say a bit more about them later on because they really gave me the structure of how my website is going to turn out. And there are two main chunks of the website. Down here, which I've called Components 2 and 3, it's all the same content. This is information that basically talks about, it's an executive summary which basically focuses on various answers to the question why. Why is an initiative around computational thinking and coding with mathematics a good thing to pursue in schools? But the main part, to me, what the most important part is, although why is very important, once we understand why, teachers really need to know how. How do I do this? And this gray section right here, this component 5 should also be in gray. This gray section right here really is how. That's the resource for teachers to use. So that's what I handed in on June 3rd. And I just want to give you a bit of a visual of where I'm at so far. This is the same image. I'll just zoom that out a bit. This is the same image, only in this case I've highlighted in yellow the things that I've actually accomplished. Okay, so as of this moment in time, I've done quite a bit of what I planned to do. Now this section over here is arguably the largest single chunk of my my project. However, it is the part of the project for which I did the most work during the planning stages at the end of our previous course on curriculum leadership. So I'm actually in pretty good stead there. Okay, so that's what I've done. Let's jump into the website and take a look. So from my main page, I go into CT coding plus intermediate math, and we have this page right here. So on this page, what I'm doing is I'm summarizing very briefly the recent rebirth of attention given to computational thinking and coding in school, different jurisdictions that have jumped on board with it, a very quick view of some reasons why we should do this. They will be talked about in greater detail in another part of my project. And then I talk here about barriers, and the main barrier I see is that A lot of teachers really don't know about it. They didn't learn it in school. They weren't trained at it in teachers college, and a lot of teachers either don't employ coding and computational thinking at all, or when they do, it ends up being rather superficial and sporadic. So got a barrier there, which led me to my inquiry question right here. How can this has kind of morphed throughout the months. How can computational thinking and coding be integrated effectively into Ontario's intermediate mathematics curriculum to increase student engagement and achievement in mathematics? Now, I read a very interesting article by Barr and Stevenson. They wrote it in 2011, but it still resonates today. And one of the many things that made sense to me from that article was their description of what is needed to create a systemic change that would allow for the effective integration of CT and coding into schools. They suggest the creation of two sets of resources, and the first set of resource would be geared towards educational policymakers, and it would define the terms computational thinking and coding. It would describe the importance of CT and coding, so answering many why questions, and then it would deal with some of the big hows. How can it be connected to existing curricula, and how it can be integrated within the larger framework for student learning and success. That's the first resource set. The second resource set is geared towards teachers, and it helps teachers get their heads around the idea, CT and coding skills and concepts, and connect them to what they already know about teaching and learning, and then also demonstrates how they might bring this into the classroom. Okay? So I've kind of taken Barr and Stevenson's suggestions and used it as a guide for my resource, but I'm not following it exactly the way they set out. I have a few issues with it. Number one, I don't know if it was their intent, but they seem to imply that this information is for educational policymakers who are not the teachers, so the teachers don't need to know this. And this information is for the teachers. The educational policymakers don't need to know this. My argument is that both audiences need to know the whole story, or as much of it as possible, and that it's very important for the teachers to know why we're doing this. Okay? Instead of just being given something and saying, here's how to do it, they need to be inspired, and the inspiration comes from why. Okay, and I'll talk about that in just a moment. So one thing I have done is I've tried not to reinvent the wheel. Over a year ago, I created this section of the website, and in it, I actually defined, you can see right here, CT, coding, and programming. I defined some terms, so instead of redefining or copying those terms to answer this question right here, I just linked it over here. So where I'm kind of indicating here, there's a hyperlink to the other section of my website, so that people can go get the definitions for computational thinking, coding, and programming. Okay. Now there are two main sections. Start with why and onward to how. So I've taken all of these ideas from Barr and Stevenson, and I've separated them into two simple questions. Why are we doing it? Why is this a good idea? And then once we understand why it's a good idea, we'll get on to how. What are some best practices? What are some resources that we can use to successfully integrate CT and coding with intermediate mathematics? Let's start with why. Now, I can go here, or I can go here. It takes me to the same place. Start with why. Now, I am aware that I need a nice image for the backdrop here. This pink is not going to stay. So I've started off in my description of why here with Simon Sinek. And if you know anything about Simon Sinek, he is the fellow who is behind the Start With Why movement. He talks about how great organizations and great people, they are successful because they start with why, and they use the why to inspire others. And so I took this idea and I've borrowed it, and putting it together with Barr and Stevenson, I've decided that all players in education, right from the people making the decisions to the people carrying out the decisions need to have a consistent understanding of why we are integrating CT and coding with mathematics, and once we understand why, we are all more likely to work together on the how. Okay, so I will be answering in this section these three questions for why. Why should CT and coding be included in K-12 education at all? And I will be talking about employability of our students in the future. I'll be talking about future building, about coding sort of being similar to literacy. You know, when Gutenberg developed his printing press, it was a slow process, but eventually literacy became a must-have. I argue that coding is kind of moving in that same direction. And then, why should CT and coding be integrated with existing subjects rather than stand alone as a separate subject? Right now, many jurisdictions who have taken the lead on CT and coding have created separate curricula and separate classes for computing science. But there is a large body of research out there that says that that's actually not the best way to do it, that it's much more effective to embed CT and coding into existing subjects, and that's better for everyone involved, particularly the students. And then the question, well, if we're going to embed them into subjects, why is mathematics the ideal discipline for CT coding integration? So these are three big questions I'm going to be answering to convince people why this is the case, why CT and coding is a good idea. In this section, I will also be describing challenges involved in integration by answering this question. What barriers stand in the way of the integration of CT and coding with mathematics in K-12 education in Ontario? My reasoning here is that there are barriers, and we can't hope to overcome them if we don't look them in the face, so we'll be doing that. Now, I have done all the research on this. I have all my notes ready to go. What I have not yet done is written the paper or created the PowerPoint. And that's the thing that I'm going to work on next as soon as I am finished filming this video, actually. So I plan on writing somewhat of a white paper or a monograph that I hope to give to the senior administration team of my board. And I'm also going to create a PowerPoint which could be used in tandem with that written piece, or it could be used as a presentation for other educators to convince them of the why. So that is coming up, and if you check back on the site, it'll be there. So onward to how. Once we know about why, we're going to go on to how. That's the question teachers are going to be asking. And if I go over here to this menu, if I click down to onward to how, you'll see that I have a bunch of MLEs. That's math learning experiences. And so there are 5 of them, 3 of which are finished, but there is a bit of a preamble, so we'll go to onward to how first. So once again, I know that I need to have an image back here. The plain blue header is not very attractive. This is the teacher's resource. This is what teachers are going to use, I hope, in their practice. So, 2 parts to this. The first part is the collection of 5 math learning experiences, and I've created room for 1 for each strand. So there will be a number sense and numeration math learning experience. There will be a measurement math learning experience. There will be a geometry and spatial sense math learning experience, patterning and algebra math learning experience, and a data management and probability math learning experience. Right now I am finished the number sense and numeration one, the geometry and spatial sense one, and the data management probability one. So let's take a look at one of these, and I'll just explain the structure that I have put in place for this. Okay, so we're going to Math Learning Experience 1, and it deals with the overall topic of proportionality. And we can see that it's number sense numeration. It's called First Past the Post. Now, a little bit of explanation. This is not about horse racing. This is about Canada's electoral system. So this lesson, this math experience, is an investigation into Canada's electoral system, which is called the first past the post system. And what students basically discover is that it's not a proportional system, as most of us know already. It is disproportionate, so that a party can get 40% of the votes, yet get a majority. So there's a disproportionality there. And then they investigate other options. But it's a good context for math. Now, each math learning experience has the same structure, so let me go through the components briefly. Math worth thinking about. Okay, that's going to be a constant at the beginning of the videos and a video of the lesson, and it takes the form of a video. And in this video, I talk about the math of the lesson, only the math. I do not get into computational thinking or coding. My reasoning here is that computational thinking and coding need to be in service of the mathematics, not the other way around. Because this is something I've witnessed in the last couple of years as people dip their toes into the water of CT and coding, is that during math class, students are working on computers on Scratch or Hour of Code or whatnot, but they're not actually doing any math. And so from my point of view, all of this has to be in service of elevated math teaching and learning. So I want to put the mathematics first. And here's just a little video about the math, and I talk about, in this case, how we're dealing with proportionality, the different types of electoral systems, and in particular how using social issues can be used to evoke an emotional response in students in math class. So that's the first section. There will always be a math worth thinking about section with these learning experiences. After we've established the importance of mathematics, then we get into a section called the CT coding advantage. And in this video, what I will always do is follow up the mathematics and explain what is to be gained about using CT and coding with this lesson. Because we should not be coding for its own purpose. If coding, or if any technology does not add anything to a lesson, if it does not increase the pedagogical value of the lesson, then we really need to question whether it's worth using or not. We shouldn't be using technology for its own purpose. We should be using technology to make teaching and learning better. So in these videos, I will be explaining why CT and coding actually elevate the lesson and make mathematical learning better for the students. The rest of the lesson follows a similar familiar pattern. We have a minds on, so a short little activity for students to kind of get their thoughts in the right direction and on the right, in the right zone. Then they have an action section where this is where they have to do something. Well, it's the main event, it's the main work and the main learning of the lesson. And in this case, the main action is right down here. I've got this scribed document that they work on. And then more action. And eventually there will be a time to consolidate the learning, options to extend their learning. And by the way, I should go back to this. The minds on will always be an unplugged activity, and this is a recommendation of Kotsopoulos et al., who wrote in 2017 in their Computational Thinking Pedagogical Framework that it's a good idea to start with unplugged activities and then follow the framework, which we'll see in a minute, to get students into deeper and more complex levels of using coding and computational thinking. So the minds on will be unplugged, and then throughout the lesson, in the action sections and in the consolidation and in the extensions, they will be onto coding environments to investigate the mathematics. Okay. Okay, I've added here curriculum expectations. Now, I know that I'm dealing with intermediate mathematics, which in Ontario is grades 7 and 8. I have added grade 6 because in our province we do have a large number of 6-7 splits, so I want grade 6-7 teachers to have the option of looking at these math learning experiences and finding that the expectations that they're dealing with are reflected in what I've created. An acknowledgement, so in this case the main inspiration for the lesson came from this particular resource called Math That Matters by David Stocker, excellent book, and then references. So that is just a walk through what one of the math learning experiences will look like. Each math learning experience comes with codes either in Scratch or Python or Jupyter Notebook, sometimes more than one of these options. The Jupyter Notebook code is found right here. These are the Jupyter Notebook files that people will use. You have to download and install it first, but they're quite cool, and you can see a demonstration of how Jupyter Notebook looks in the video up here. So that is the basic structure for the math lessons, and if we just kind of take a quick look at, let's go to the Math Learning Experience 3, Geometry and Spatial Sense, the Wheel of Theodorus, you'll see, again, math worth thinking about, the CT coding advantage, a minds on, an action section, a consolidation section. Oh, we have another action section here. This one's extra special. More consolidation, an extension, curriculum expectations again, acknowledgement, references. So that's the structure. Now, let's go back to onward to how. So there are 5 lessons, but teachers, I hope, will want to create their own lessons, and so I want to give them a bit of help. First of all, the lessons that I've created will hopefully serve as a nice model for them to follow, but I've also developed down here an infographic that they can use, guidelines for integrating computational thinking and coding into mathematics instruction, and this infographic summarizes some basic guidelines to follow so that they can develop their own. Keep math as the focus, keep the rigor high, and here I sort of describe how our curricula and our educational cultures tend to focus on what kids can't do, thanks to the work of Jean Piaget, who his stages of cognitive development sort of gave us a deficit mindset, and how we need to break through from that. This here is the pedagogical framework I was mentioning, how we should start with unplugged, move to tinkering, move to making, move to remixing. Some of that is summarized here. And then a little bit on the aesthetics of mathematics. So it is my hope that this infographic, combined with the lessons that I have created, will help teachers create their own lessons. One thing that I should point out, and I'm just going to go back to one of the lessons, is that in the lessons I've embedded various items like this, these colored bits of wisdom, and some of them appear as slideshows. In these boxes I have put notes of a mathematical nature. I've also included notes about affordances of CT encoding, so what it is that kids are doing, what CT coding skills they are learning and using. I've also included in some of these notes planning suggestions, like why we're doing an unplugged activity first and that such thing. So that is my my draft so far. That's what I've done for my capstone. And so just a couple of things to summarize. Here are some of the steps that I need to follow in as we kind of close this out. I need to write my executive summary and take that same information and create a PowerPoint. That's the next thing I'm going to work on. I also have 2 lessons left to do, one for measurement and one for patterning and algebra. Now I'm going to be very, very honest here and say I have a good idea of what I'm doing for patterning and algebra, but I've been having a real struggle coming up with ideas for measurement. Just thinking about the measurement curriculum and how I've taught it over the years, I really, really like the way that I've done it in the past. Very hands-on, very tactile, and I'm not sure that I don't have a good idea for a coding application. So one of my questions is, for all of you out there, is do any of you have a good idea? Do you have any suggestions for me for a way that I can weave coding and computational thinking into a lesson? So I'll just leave that with you guys to maybe give me some advice. The other thing I will point out is that if you do visit my site, and if you do happen to go to one of the lessons and you watch the videos, you may detect that they are rather amateurish, probably much like the video you're watching right now. So my plan is, once I am done all the other components and I have some time, hopefully, to go back and fine-tune my product, my plan is to watch the videos that I've made, create word-for-word scripts, and then re-record them so I don't sound like such an amateur. I did write speaking notes when I made these videos, but they weren't enough to prevent me from tripping over my tongue. And as endearing as that is, it's not very professional, and I want people to take me seriously. So that is one of my goals as I look forward to finishing this project. Now I think that is just about everything that I have to say. So I thank you for your attention if you managed to stay with me this long, and best of luck to everybody as you finish your capstones. Cheers.